Hello, in this video we will talk about the area of the triangle. So how we can find the area of a triangle using the determinant equation of line. You know, if I draw three different points which are not on the same line, I can always draw a triangle by joining 3 points. If the 3 points are on the straight line, then I cannot draw a triangle because they are on the straight line. But if I make this point a little away from the line, then I can make triangle, this and this. Okay, so every 3 points will make triangle. Let's look. Suppose we are given 3 different points: x1, y1, x2, y2, x3, y3. So these are 3 different points, A, B, and C. So these 3 different points will, if they are not collinear, then we can make a triangle, and the area of the triangle is area of triangle formed by these 3 points is area ABC. Why I'm writing ABC? Because my points are A, B, and C. Okay, so area of the triangle formed by ABC is equal to 1/2 times the absolute value of the determinant. The determinant is x1, y1, 1, x2, y2, 1, x3, y3, 1. So this is the determinant, and these lines are for absolute. Okay, so this is called the absolute value of the determinant. Absolute value of determinant. Okay, so we are given 3 different points, and we have made the triangle, and whose area is equal to this. We have to prove it. Okay, here is the proof. What we have to prove: whenever we make a triangle by given 3 points, then the area is equal to this. This is what we have to prove. So in order to prove, first we will draw 3 different points. Suppose this is A, this is B, and this is C. Okay, let's make C here. Okay, now if I draw a straight line passing through AB and also make the triangle. Okay, so we have a triangle and a straight line passing through points A and B. You can draw this line anywhere. I mean, you can draw this line here, or if you want, you can draw a line here. Wherever you want, it's up to you. But I have drawn a line on AB. There are 3 different possibilities you can draw. Now let's do a construction. The construction is draw a perpendicular from this point to the line. Okay, so I have drawn a perpendicular from the point C to this line AB. Suppose this is the point, this is called H, where it is intersecting. The perpendicular is intersecting to the line AB. Here, this angle is 90 degrees. Then, the area of this triangle means this area, which is inside, is equal to area of triangle ABC is equal to the distance from A to B times the distance from C to H divided by 2. Okay, here in this formula we need to find the distance of A and B and the distance of C and H. Since a and b are given, so a is equal to x1 y1 and b is x2 y2, so we can easily find the distance of a and b by using distance formula. So I will write by distance formula, I have to find AB and CH. So by distance formula, I can easily find the distance of A and B. The distance of AB by using the distance formula is square root of x2 minus x1 square minus y2 minus y1 square. This is because of the distance formula in the pre-algebra course. Okay, this is what you have to memorize. If you are given any 2 points, x1 y1, x2 y2, then the distance is the difference of the first two square minus the difference of the second two square. Okay, what you have here, and the whole thing square root. This is the distance formula. So this thing has already been found. Now we have to find CH. When I will find CH also, then I will put this value and CH value in this equation, then I'll get the area of the triangle. Suppose this is equation number 1. Okay, so this AB is ready. Now I have to make this ready. Since you can check, this CH is nothing but the distance of a point from this line. I mean, this is the line AB passing through AB, and the distance of this point from this line is this one. Okay, so CH is the distance of a point C from the line. Okay, so I have written that CH is the perpendicular distance of that point C from the line AB. Okay, so I don't know what is the line AB, but we know from the previous stuff which we have done in the previous section that the line AB can be written as ux plus vy plus w is equal to 0. So the line AB, the general form of line is ux plus vy is equal to 0. Since CH is the perpendicular distance of C through the line AB, since again from the pre-algebra we know that the perpendicular distance of a point through the line is u times x plus v times y plus w, the distance of the line, divided by this thing squared plus this coefficient squared square root. But this is just the line, this is the square of the coefficients, but we have to find the perpendicular distance of this point through this line. So it is obtained by putting x3 here in place of x and y3 here in place of y. So I will write here x3 and y3. This is by the formula from pre-algebra. Okay, so the distance of C through the line AB is represented by this thing. This is all previous stuff. I am not going to prove that how this distance come, but this is through the formula. And here in this formula, again, this is an equation of line of AB. This is the equation of line of AB. And this is just the sum of the squares of the coefficients of the line, okay, and then square root. But the equation of line of AB, I have just written the general form of equation of line, but the particularly equation of line for the points AB, since the points of AB are x1, y1 and x2, y2, if I write the equation of line of AB in matrix form, in determinant form, the equation of line of AB is, it's very simple. Just from the previous video, it must be x, y1, x1, y1, 1, then x2, y2, 1. It is equal to 0. Okay? Now, if I expand this determinant along the first row, along the first row, first of all, I will write this element times the cofactor based on this factor, this element, which is -1 to the power 1 plus 1 times x times the determinant of submatrix obtained by deleting this one and this one is y1, 1, y2, 1. Again, plus -1 to the power 1 plus 2, because I am going to this element, because I have to expand along this first row, and this element is in the first row and the second column. So that's why 1 plus 2, and this element is y, times the determinant obtained by deleting this row and column, which is this one and this one. x1, x2, 1, 1. x1, x2, 1, 1. Plus -1 to the power 1 plus 3 times 1, because now I am moving towards this element. Okay, this element is in the first row and the third column, so that's why -1 to the power 1 plus 3, and the determinant obtained by deleting this row and this column is x1, x2, y1, y2, just these things. Okay, this whole thing is equal to 0. If I simplify these values, this is equal to plus 1, because -1 to the power 2, 2 is even number, so I will just write x times this determinant. So I will write y1, 1, y2, 1 times x. It doesn't matter whether I write x here or here, doesn't matter. Okay, and this number is -1, because -1 to the power 3 is odd number, so I will write negative of the determinant is x1, 1, x2, 1 times y, plus, because this -1 to the power 4 is even number, so I'll write plus, so plus x1, y1, x2, y2 equals 0. Okay, so since the general form of equation of line was ux plus vy plus w equals 0, if I compare this thing with this one, so that means u is equal to this, v is equal to this, x is this one, y is this one, and w is this one. Okay, so since I have found what is u and what is v and what is w, now I will put my u, v and w in this equation, and so this equation will become, actually this is the distance of CH. Okay, so I will write the distance of CH is equal to just this thing. Since I have found everything, now I will just put the values. CH is equal to this value, and here u, v and w are found. This is my u, this is my v, and this is w. So put u, v and w here, u, v and w, and here also. Okay, so I'm going to put these values here. What will I get? U is y1, 1, y2, 1, y1, 1, y2, 1 times x. Okay, not x, because u times x3, so I will write here x3. So u times x3 plus v times, what is v? V is this value, so x1, 1, x2 1. So sorry, so v is actually this value but with negative elements, so I will write here negative, and y3 here, because v times y3 plus w. What is w? W is this whole determinant, so I will just write this determinant plus this determinant. Okay, and this is the absolute value, so I will write the absolute value divided by u square plus v square. This is u and this is v. Okay, so I have to write u square. So first of all I have to write square root of u square. U square means y1 1, y2 1, this whole thing square, plus v is this one. So I will write x1 1, x2 1, whole thing square. I am not writing this minus because when I will take square, this minus will killed. Okay, this minus will get cancelled. Okay, now I have to do these all calculations. If you think this is 1 times, you know, this can be written as minus 1 to the power 1 plus 1 times x3, because this is x3 and this is minus 1 to the power 1 plus 1, just as previously, which I have, if you don't want to write, just let's write this whole thing in this way. x3, okay, just this way, x1 y1 1, x2 y2 1, x3 y3 1. I mean, this whole thing, actually inside this whole thing is the determinant of this. Okay, this you can check by expansion of this determinant. Since there are absolute values here also, so I have written down the absolute values. Okay, so if you expand this determinant along the last row, along this row, you will exactly get these values. Okay, so that means this whole thing is equal to this determinant, the absolute value of this determinant. Now, what is in the denominator? The denominator is square of this thing. Okay, so this thing is just y1 times 1, which is y1. I will write y1 minus the product of these two is y2 square, plus this, plus again the determinant of this x1 minus x2. I will write x1 minus x2 square, but everything is under the square root, so I have written down the square root here. If you want to if you want to change their positions, if you want to write x2 minus x1 and y2 minus y1, it doesn't matter because this is square. When I will change their position, we will have minus common, but that minus can be killed by this square. Okay, similarly you can take minus common from these two, you will get x2 minus x1, and the minus which you have taken common can be killed by this square. Okay, so I have changed their positions. So this is actually c times ch, the distance of ch. Okay, now we have ch also, we have ab also. Here you have AB and you have CH also. You can put all of these values in the equation number 1, which is the area of the triangle. So equation number 1 can be written as area of triangle ABC is equal to 1 by 2 times AB times CH. Put the values of both AB and CH. The value of CAB is from the above, we have x2 minus x1 squared plus y2 minus y1 square whole square root times the value of CH is just this value. So I will just copy this value and paste over there. So I have written down this 1 by 2 as it is, this value of AB and this value of CH. Okay, now if you check, this whole thing is cancelled by this thing because they are same, but one thing is in the numerator and the other thing is in the denominator. So the area of triangle is just 1/2 of the absolute value of the determinant. x1, x2, 1, y1, y2, 1, it is x1, y1, 1, x2, y2, 1, and x3, y3, 1. Okay, so this is what we had to prove, so we have proved it. Now we have a problem. The problem says find the area of the parallelogram. Parallelogram means you have three different vertices and you join them, and the vertices, points are given A, B, C, and D. You have 4 different vertices. Since through 3 different vertices you can always form a triangle, but through 4 different vertices you can always form a parallelogram. And look, here you can make the parallelogram. For example, these are A, B, C, and D. In this way, you can make parallelogram. Okay. Since if you want to find the area of the parallelogram can always be divided into 2 different triangles. This one is one triangle, the other one is another one triangle. Okay. So we will use this technique. So we have to find the area of the parallelogram. Here is the solution. So what we will do, we will draw 4 different points A, B, C, D. We have to find this whole area, but in order to find this whole area, we will divide parallelogram into 2 parts, A, B, C, D, and we will find this area because we know how to find the area of the triangle. Because we have proved this theorem, the area of the triangle is obtained by finding this determinant and then absolute value and divided by 2. Okay, we will use this formula to find the area of this triangle, and then we will double this area because this whole area is double of the area of the triangle. So this is the procedure which we will do. Okay, so first of all, I will write this argument that each parallelogram can be divided into 2 congruent triangles. 2 congruent triangles means those triangles which have the same area and same dimension. So that means we have divided our whole parallelogram into 2 congruent triangles. What we will do, we will find the area of one triangle and then multiply that area by 2. That means we are getting the whole area. Okay. So the area of triangle ABC is just by the previous formula. The previous formula is 1 by 2 times the absolute value of the determinant obtained by 3 different points of ABC. Okay, it is x1, y1, 1, x2, y2, 1, x3, y3, 1. Okay, so what are ABC? Here ABC are given. So this one is x1, this one is y1, this one is x2, this one is y2, x3 and y3. We will put these values here in this formula. So the area will be one by 2 times the absolute value of x1, y1, 1. That means x1, y1, 1 means 0, 0, 1. x2, y2, 1 means 3 minus 2, 1. 3 minus 2, 1. And then x3, y3, 1 means 4 minus 1, 1. Okay? 1 by 2 absolute value. Now expand this determinant along the first row, because first row has 2 zeros, so it's easy to expand along the first row. Okay, so first of all I will have the cofactor based on 0, so that will be 0. I will not write this. And then the cofactor based on this 0, again 0. I will not write this. I will only write this cofactor. I will write minus 1 to the power 1 plus 3 times this 1, and then the determinant of the submatrix obtained by deleting this and deleting this, which is this one, 3 minus 2, 4 minus 1, absolute. Okay, now this minus 1 to the power 4 is even number, so I will write plus 1 times the determinant of this one is 3 times minus 1, 3 times minus 1 minus 4 times minus 2. Okay, 1/2 of absolute value, 3 times minus 1 is minus 3, minus minus plus, so I will write plus 2, 4 times 8, 1/2 of 8 minus 3 is 5. Absolute value of 5 is 5. Okay, if it was negative 5, then the absolute value was again 5. What does absolute value do? Absolute value makes everything positive. If it is positive, then the absolute value is the same number. If it is negative, then the absolute value will be its positive number. For example, this time it is 1 by 2 times 5, because 5 is positive number, so it is 5 by 2. Okay, so this is the way how we find the area of the triangle or the parallelogram. If you have parallelogram or square, you will divide it into 2 different triangles, and then you will find the area of one triangle. So this is the area of one triangle. In order to find the area of the parallelogram, we have to double this area. Okay, so area of parallelogram is 2 times the area of triangle. Okay, 2 times area of triangle ABC, which is equal to 2 times area of triangle was 5 by 2. I have to put here 5 by 2, cancel these 2. The area of parallelogram is 5 square unit. So this is the answer.